thank you very much for having me. This is the first time I'm presenting in the track at the Groundbreakers Tour for Latin America, so I'm very honored to be part of this. I know that we've got a few of my colleagues joining me after my presentation, so this is a jam-packed agenda, very full of really good speakers, and I'm looking forward to going through my slide deck, which is currently open at Terraforming the Oracle Cloud. And it's something I've put together some time ago. I have presented this at the UK Oracle User Group in 2019, and I got really good feedback to it. And that's the reason I decided to put this forward for this audience as well. So I hope you enjoy it. Now I just need to figure out how to go to the next slide. There's so many, there we are, so many windows open. Right, so the agenda is gonna be some context around Terraform. I would like to warn you straight away, if you were hoping for a Terraform start to finish 101 class, then this isn't going to be it. It's more of a session about the context around Terraform and why Terraform and what it does. I'm going to do a very brief introduction to cloud concepts, because at the end, what I would like to do is I would like to show you a little bit of code and how to quickly spin up infrastructure in the cloud with very little effort. And most importantly, it's always very repeatable if you have it in code. And I couldn't resist to do a little bit of Terraform basics after all. So I'm going to introduce the basics to you and how Terraform works. And finally, I'm going to have an example as well, which is, of course, a very basic example, and it's not production-ready code. It's stripped down to the bare minimum of what we need in order to spin up a few virtual machines in the cloud. So that's the plan for today. Okay, so a little bit about myself. I work for the Accenture Architect Group. I think that's pretty much all I understood from the Spanish introduction. I'm helping customers with their projects around the world. And what I'm saying here is strictly based on my own opinion. And I've contributed to a bunch of books about the Oracle database and the Oracle database infrastructure and ecosystem. And I'm on Twitter and I like blogging. So if you've got any questions that you would raise afterwards. I think we've got a Q&A session after this presentation anyway. But if there is anything that comes to mind, good, bad, ugly, just put it onto Twitter and I'll be happy to address your questions as they come up. Okay, so before I'm diving into Terraform and what it is and how it works, I would like to add some context to Terraform. And I apologize for the slide. It's very text heavy. I kept this for later on when people who haven't seen the live stream or when they haven't attended this live session, that you have something to read up on. So don't be worried. I'm not going to make you read this slide. This is just a summary slide for those who are joining and reading this afterwards. Okay, so Terraform is something I'm very interested in, simply because it is one of the ways in how I can create infrastructure in the cloud. And I've been involved in more and more cloud projects recently. And the last thing I like doing is pushing the mouse over a graphical user interface. So a lot of the tasks in cloud computing are pretty repetitive. And so one of the ways you can get started, and if you look at those tutorials that tell you how to get started with clouds, and it doesn't matter which one, it's usually involving logging into some sort of a web interface and then navigating around the web interface, clicking here and there and creating your cloud infrastructure if you're so inclined. And that gets really tiresome after a while. And just like with on-premises deployments, which I try to automate as much as possible, because after the 10th time, even the most exciting task gets pretty boring. I like to have it all automated. And the more important thing is I want to have it in exactly the same state every time I run my piece of code. So I can't really afford having slight deviations. And it's in human nature, and I'm by no means exempt from that. If you have imagine you install the Oracle database on 10 different servers is a typical example. At one point, your attention slips off and you tend to make certain mistakes. And with code, the computer never gets tired executing your code. I mean, you'd hope it's good code, because the computer also doesn't get tired executing bad code. But the important thing is that it doesn't get tired doing things just like humans would do. So this is why I like everything in code as much as possible. And with the cloud, there is a big differentiator to on-premises deployments that we did 10 years ago at large scale, where we put machines into data centers, or when you created a new project and you went off to somebody and you asked for budget because you need to buy equipment for multiple tiers, production, disaster recovery, and various UAT, dev test integration, and so on environments. You'd have to buy all of this, and it had to be delivered, had to be shipped into the data center. Somebody had to wire it, it had to be cabled, cooled, and all these things. And quite frankly, it takes a long time to do. So even if you've got budget approval done quickly, it usually takes a little while for things to hit the floors. And that is delay in the project. With a cloud, as I say here in purple, you don't own machines. It's just rented, if you like, without having to worry about the infrastructure. So you just declare what you want to use. And in the example here, we're going to declare this in code, in Terraform code. And there are multiple ways on how you can do this, and I'm going to explain them in more detail later on. But just to mention these things here, there is a firm belief in on both sides of the camp. Some people believe in mutable infrastructure, and some believe in immutable infrastructure. And I'll go in, like I said, I'm going to go into more detail as to what that means. Then we've got a procedural versus a declarative approach, and that's how you write your code and how you use it in the end. But all of those follow the infrastructure as a code approach. And here with Terraform, it's really difficult to make the distinction between the two types of things that you can provision. So Terraform has evolved. When I first looked at it, it was more or less a tool to create what we call infrastructure as a service. So it's the lowest of all the cloud tiers, where you have most control and also most responsibility. And one layer above, in traditional literature, you would find a platform as a service, and that would be your database services, where somebody else runs the database for you. So less interaction with the actual thing, at the expense of less control. So you've got to live with the service as it is provided. And Terraform can do both. And that's why I'm saying sometimes you don't even have to provision VMs at all. Enough about the context. Why do I think Terraform is awesome? It simply is a tool which you can use to write what you want well, initially it's a bit difficult to read and write, but after a little while it becomes second nature. So if you look at the cloud documentation of various vendors, you will see they kind of all embraced Terraform. It seems to be the accepted standard way of provisioning IaaS and PaaS services, at least from what I can tell. And pretty much everyone has its own toolkit on top of Terraform. So knowing Terraform enables you to use the cloud toolkit, which further enhances the experience, as we, I think, as we tend to say these days. So for example, the Oracle Cloud uses something called Resource Manager. And that obviously uses Terraform, and it looks very promising. But it's not part of this talk, because you need to understand Terraform before you can make use of Resource Manager. At least that's my experience after having looked at it briefly. But I would still like to tell you there are tools out there which are kind of abstracting from the basic way of writing Terraform. But it's still, you need to understand what Terraform does before you can have an abstraction layer on top of it. And the other thing worth pointing out is that Terraform isn't config management. So there are two broad categories on automation tools in my book. And one of them is the Terraform, where you provision infrastructure. And in many cases, that's virtual machines in a cloud. But that gives you a virtual machine in the cloud, and every cloud vendor gives you an operating system, and they call this image usually. So in Oracle, they give you Windows, they give you CentOS, they give you Ubuntu, they give you Oracle Linux, obviously. And those are your images, and you can pick which one you want, Oracle Linux 7, for example, and of course, Oracle patches these and makes them available as new versions of the same image. So that's one thing. That if you then go ahead with Terraform and you create a VM based on an Oracle provided Oracle Linux 7.8 image, you will get, well, you get that. It's the same thing as if you were to stick an ISO image into your CD, into your DVD drive and you install, or whatever abstraction method. So that provides you the infrastructure, but it doesn't give you the app on top. So if you want to put an application on top of it, there are multiple ways in how you can do this. If you're not currently looking at containerization for your application, then things such as Ansible, Chef, Puppet, and Salt are very popular ways of configuring a provisioned VM. Okay, but obviously it depends on what you want to do. Okay, so thinking about your favorite form of deployment is one of the things that you need to do before you get into the whole business of Terraform writing. So the first three, in my opinion, are pretty much obvious. So you've got an infrastructure as a service instance, which is kind of a naked, so to say, Linux operating system, a VM with storage attached to it, CPUs, memory, that's the thing. And then you can run Ansible, and Ansible will put whatever you need to put on top. So for instance, I'm using Ansible to deploy the database a lot. So I can, I get a VM, I run my Ansible script, playbook as it's called, and it puts an Oracle database on top. Okay. So now if I'm doing this frequently, I may want to use golden images. I call them golden images. It's not the right term, but it kind of captures the idea. Whereas you have you've got a bare naked VM onto which you run your Ansible playbook. The Ansible playbook then installs your application, and once it's done, you can create a custom image based on that VM. So that can be done through the GUI, or you can do it in code as well. And there is a tool called Packer, where you can say create a VM, run a provisioner such as Ansible on top, and it creates the application. And at the end, it will create a custom image, and it gives you an identifier in Oracle Cloud as the Oracle Cloud ID. And later on in Terraform, you can then reference this one and say, hey, I want to build a VM. So for example, you could build Oracle XE and then create a custom image of your XE build, and you then spin this machine up. So you save yourself the time of running the Ansible playbook to install Oracle XE. Okay, so that's also possible. And one step above is obviously you use platform as a service. So you use the Oracle database service, for example. And there are a couple of others, which I'm not going to cover here. Self-hosted Docker containers is something else. I'm not going to talk about Docker here because it's not kind of in the context of Terraform. And if you take the Docker game one step further, then you use a container framework, but neither are part of this talk. So speaking of configuration management tools, I always have to mention Ansible because I'm such a great fan and I've used it extensively over the last 2 years and with great success. But Ansible is just one example. There are tools such as Chef, Puppet, and Salt, which are config management tools. And Ansible, from what I can see, is the most popular. So there's a lot of talent in the market. There is also a lot of stuff out there on GitHub gists, blog posts, Medium, and so on. So it's easy to find some problems solved already that you are trying to solve. So with clever search engine skills, you can solve pretty much every problem with Ansible. Of course, you'd have to understand Ansible in the first place, but you can find out how people do solve problems. And it's, even though Ansible evolves quickly, it's pretty backwards compatible. So something that you find on the net is probably still applicable today. But as always with stuff that you find on the internet, it's your responsibility to make sure it works as intended. The great thing about Ansible, I think, over Chef and Puppet is that it's agentless. So all you need is a Python interpreter and SSH access to the box, and then you're off. So it's pretty cool. Ansible scripts are called playbooks, and you write them in YAML, which is yet another markup language. And if you look at the history of how things have been configured, there were times when we did XML, and XML wasn't fancy enough, so people invented JSON. A very brief history of that. But JSON is facing competition with YAML. YAML is the way you write Ansible playbooks and a few other things as well. And with Ansible, you define what you want your environment to look like. And then you run the playbook. And as you will see later on in the example that I have, I'm installing the Oracle XE database, completely hands-off. I just run this playbook. And after a little bit of time, because I need to download Oracle XE, it installs, it creates a database, and I'm done. And the good thing about Ansible as well is that you can reuse your code. You can write it very modular. If you think about how you want to lay it out for reusability, it's pretty easy to make your code reusable. And the main way on how to do this is via roles, Ansible roles. It's a pretty good concept. Okay, and what I said before, Packer is just like Terraform. It's part of the HashiCorp toolset. And you can use Packer for many things. One of the most common, from what I can see, is to create identical VM images, and it supports many platforms. Pretty much, most on-premises virtualization solutions. And just today, I wrote a small blog post about using Packer to create Vagrant base boxes. So there's another virtualization technology I use a lot based on Vagrant and VirtualBox, and it's completely hands-off. So that's nice, but it also supports all the major cloud providers, including Oracle. And for instance, the way it works with Oracle is that you define which base image to start off, say the most current Oracle Linux 7.8 on a given shape, say VM standard 2.1 in the Oracle Cloud, and you give it a network, and then you can connect, and then Packer then goes off. And based on your definition, it spins up a VM. It runs Ansible in my case, but there are many other provisioners such as Shell and others that you can run. So it provisions the VM. And then at the end, when it has provisioned the VM, it will create a gold image or like a custom image in cloud speak and upload it into your compartment in the Oracle Cloud. Same for AWS and Azure. And then you can reference your golden image or custom image and use it in Terraform. So also a very nice tool. Okay, usually, as I said, it results in custom images, which you then spin up using Terraform. Why would you do this over running Ansible on top? In my opinion, it's just a matter of winning time, and also you eliminate the risk of your Ansible playbook running into some error conditions that whatever obscure stops and causes your build to fail. So that's not something you want. Speaking of deployment options, just previously on the first slide, I mentioned a couple of design principles, and there is immutable and mutable infrastructure. And when you look at resources about Terraform and other cloud infrastructure as code technologies, you find that discussed at least a little bit in every book or lots of articles. So what is this mutable infrastructure? Essentially, it means you create a virtual machine or you create some other cloud infrastructure, and you are allowed, or you allow yourself to log in to that piece of infrastructure and make changes to it. That is usually done by humans, ideally done by configuration management tools. In my experience, it's unlikely to succeed when you apply this at scale. And I think anyone in this audience who has been managing 50 to 500 databases, you will appreciate that at a certain point in time, The systems get deployed, they're all pristine, they're all built to specification, but after a while, some systems get changed here, some systems get changed there, but there is no consistent change being applied to all of the VMs, all the machines in the fleet, and that results in configuration drift. And configuration drift is always difficult to deal with, especially in exceptional situations such as disaster recovery, which you're not planning or rehearsing if you've got to do it for real. And it turns out your DR system hasn't been patched on, or is lacking essential configuration options that you have previously applied to your primary databases, which is now gone and you can't look at it again. Okay, so difficult to do. And this is why people have come up with the idea of immutable infrastructure. It's definitely not like a switch where you can say, I'm going to switch from mutable to immutable infrastructure. It's definitely a big change. But the idea behind it is that once you deploy your artifact, and it's very often associated with Docker, actually. Once you deploy the thing, you're not going to connect to the artifact in whatever way. So you don't use config management tools, you don't use SSH to log in. The idea is that if you find a deficit, you go through your CI/CD pipelines and your incident management and tracking, and you build a new artifact which has this defect fixed, and that artifact then replaces what you have. And there are many ways of doing this, like canary deployments, blue-green, and so on. But at the end, the result will be your application is kind of rolling change to a new version. Fixing this problem, but you wouldn't log into your Docker containers and change config files or do other things. That's just not what you do. And tools such as Docker and Packer are very often found in these kind of situations. Higher chance of success when used properly at scale, and then properly here is the key thing. It requires a lot of effort to, kind of the initial effort to get to that is very steep, but once you get there, the effort of deploying changes is probably less. I wonder though how much immutable infrastructure would be applicable to the Oracle database, because it's really difficult to put into immutable infrastructure. So yeah, I haven't got an answer to that question yet. So how you'd go about mutable infrastructure, that's very close to how we do things today. So you would just create the virtual machine, like using Terraform apply. Sorry, that's the command. The Terraform interpreter is the tool which converts your code into infrastructure in the cloud. And once it's done, you run Ansible playbook, and you can SSH into the virtual machines and use them from there, which is allowed because you've got mutable infrastructure here. The idea, though, is that every system looks alike, and that's definitely true at the beginning when you have deployed it. The question on whether it's still true when you have it in production for a good couple of months or even longer remains to be seen. With Ansible, what you would do is you create a VM using Terraform, you install the RPMs and configure the operating system. You could clone the Oracle Home from your golden image, which has all the packages the patches and options enabled as you need. And it's also tested and hardened. You deploy that and then further harden and customize the installation for your needs. So that's how you would ideally do this using Terraform. Immutable infrastructure, very different kind of idea. So here you would say, for instance, I need to have a new release of my database binaries. So you could define the contents of your future image using VI or Emacs or whatever other editor you would use. VI is probably the least common denominator. Visual Studio for Code is something that works quite well. I use that a lot. So you define what you want, then you run Packer to build the artifact, and then you use Terraform applied to deploy that image, which Packer just created. And you do not make changes to the image you have deployed. The image is pre-configured. Now, the question is, can you do this with the Oracle database? It's definitely an evolved process. Like I said, it's no easy answer whether this is better or the immutable infrastructure. It depends always on your in-house skill set, your willingness to change, and also yeah, your kind of tool chain in order to get this to work. But I can see it work. Need to update the package. So you would create a new Packer build, you test it, and then you replace the outdated version with a new image. But again, you would replace something rather than go about and change it. Of course, you wouldn't delete anything that's important. Right? That goes without saying. Okay, cloud concept. So before I'm going to go into a little bit more detail, I'm going to talk about the cloud concepts that we need for this session. So the picture here on this slide is actually taken from a white paper called Best Practices for Disaster Recovery in Oracle Cloud Infrastructure, and it's been updated in January 2020 for the last time. So this shows you that many cloud deployments are actually a little complex. So here, what we have here is a cloud region for the Oracle Cloud. And within the cloud region, you define a network, the virtual cloud network. And that's up to the right, top right here, the VCN. And within your cloud network, you can subdivide that into so-called subnets. And within your subnets, you've got tools such as load balancers, because you don't want to have a single point of failure for your application. The load balancers load balance requests to your web tier, which we have got sort of in the middle, web server VMs in subnets A and E, and the web servers connect to one of the database instances. And so there is database system in subnet B, and there is one in subnet F. And in here, you can see that the one in subnet B is operating in the primary role. And it is using DataGuard to sync with a disaster recovery copy in a different subnet. So the other thing that you should probably be aware of is that we subdivide regions into availability domains in the cloud. And within those availability domains, the idea is that systems deployed in one are not affected by any potential problems in the other. So AD1 and AD2 should be completely separate, and when one of them fails, you can resume operations in the other one. So you've got a fairly resilient system being built out here in this little schema. So, as I said, virtual cloud network is based on regions, and the next subdivision from the virtual cloud network is the availability domain. Think of them like I think one of the analogies being used is an independent data center. And within the various data centers in the availability domains, you've got fault domains. And those are, again, separate entities, out of which you've got 3. And the failure of one fault domain shouldn't affect any of the other 2. So that's the hierarchy, so to say. Then you've got subnets and security lists and network security groups. Think of those as virtual firewalls that you can use. And then you've got, of course, route tables. They tell you where to route the traffic to and from. Load balancers make applications highly available by spreading the incoming requests based on an algorithm that you can choose against the VMs that you run in your middle tier. And the middle tier then talks to the database system in the backend. And in order to get all the communication going, there are various gateways, such as an internet gateway. This is where the internet traffic comes from. Network address translation gateways would allow systems in non-public facing subnets to get and receive traffic. Dynamic routing gateways, as you see one here on the left-hand side, DRG, that's being used to connect your on-premises data center against your cloud network. So lots of things to look at. And finally, in terms of virtual hardware, there are these instances. Oracle Cloud offers bare metal instances in the classic IaaS context. There are also virtual machines. There are variations of the ones, and obviously you've got the database services, but those don't discuss here. The image I have mentioned is the operating system that's being used for your virtual machine, and that can be Ubuntu, Windows, Oracle, Linux, CentOS, and some others. And it changes quite frequently what they support, and they support more and more with every release of their software offerings. So have a look at those. I personally use the Oracle Linux images the most. And finally, shape. Shape defines the combination of network, disk, and CPU, memory, and network characteristics, and the number of storage units you can attach to, or whether you've got directly attached NVMe storage. I mean, it's kind of the characteristics that they range from pretty small to pretty big, or insanely big, actually, in the Oracle Cloud. Okay, so having talked about the introduction, it's time now to look at what you need to do if you want to spin up those things using Terraform. So there are a few prerequisites that you need to meet. They depend on your provider. Each provider is different, and you should check the documentation for more details. In the case of Terraform for the Oracle Cloud, you will need to complete a number of steps, and they're actually the same whether you use the Python SDK, whether you use Ansible, or you use Terraform, and even Packer. It is pretty much the same thing. So you first need to create an API signing key, which authenticates you against the GUI, or well, the backend, the API backend, the REST API, and it says, hey, you're authorized to create those resources. And the public key needs to be uploaded to the OCI console, which is what you do once. I usually assign a keyword to the primary, to that private key, so additional level of protection in that respect. And then you need to look up a few cloud identifiers, one for the tenancy and one for your user. And that's actually pretty well documented in the official docs and also in lots and lots of blog posts. So it's pretty easy to do. And once you've collected all that information, it's about to think about the syntax of Terraform. And Terraform uses the HashiCorp configuration language, HCL. And it's just, well, not so recently, but some time ago, Terraform 0.12 came out, and it introduced a new version of HCL, and I like it a lot more than HCL1 because it's easier to read and it's more pleasing to the eye, which is weird because most examples you will find are still based on HCL1. It still works, so you can still copy paste those examples and use them in your own code or modify them for your own use. But I would recommend, if you can, and start new now, go with HCL2. And the docs are pretty good. I've got the URL down here, terraform.io, docs configuration, that's where you find it. HCL2 is actually used in Packer as well from 1.5. So knowing HCL2 is actually not a bad thing. Oh yeah, and I just should say that Terraform has just gone to a 0.13. So key elements of the language include providers and then resources, and within those you use variables, blocks, and expressions. So on the right-hand side here, you see a little example where I'm creating a virtual cloud network, a VCN. So you can see the syntax is always the thing you want to create, like the resource, and then you look up the resource type for an Oracle Cloud Infrastructure Network, and that's called OCI Core VCN. That's the resource you want to create, and you give it a name so you can reference it later on in your code. And as in the GUI, you need to give it a CIDR block, so you need to tell what address range to contain. It needs to go into a compartment, and yeah, it needs to go into a compartment, and you can assign a display name. And PowerPoint again mangled my double quotes, which I don't like. And it also gets a DNS label. Those are the things that you can assign. There are many more. Look at the documentation, what you can assign. But it's the same as you would do in the GUI, so no difference from there. You just need to put it into code. And in order to not repeat yourself, very often you find examples, and here is no exception, where you define the CIDR block here as a variable. So I've got a variable called VCN CIDR block, and that contains the CIDR block. So I don't need to go and do global search and replace. The same is true for my compartment. So that's also a variable that I'm passing. Okay, then the first thing you need to do before you can actually use your Terraform resources is you define which cloud you want to use. And in our case, the OCI provider is used for Oracle Cloud Infrastructure. And this is where you need to put those details that you fetched at the very beginning. So you need to tell it the OSITs for the tenancy, the user, the key fingerprint, the private key path, the region where you want to create your resources. And if you're using a private key password, you also pass it on here. And you see those are all variables. So there is nothing hard-coded. You should never hard-code any of that anyway, because if you put it into version control, that's really information that shouldn't go there. Now, if you could think of Terraform as something that you can write once and run everywhere, it's not Java. So it's unfortunately, it's not possible. Although every cloud, every major cloud supports Terraform, the APIs are too different for having just one layer of Terraform code and then simply switching from one cloud to the other. That doesn't work. But as soon as you've got the provider OCI in your code here, you run a command called Terraform init. It pulls the code, latest release of your software driver, so to say, and allows you to go ahead with your code. And as I said, you define what you want in your code. So in my case, I've got a cloud VCN that I created, and I've got an internet gateway, and again, you need to just populate those values in the resources. And the way I do it is, if I don't know it by heart, I look up the various pages on the documentation. I look up what do I need for OCI core internet gateway, and it tells you the mandatory and the optional attributes that you need to provide. Usually it's a compartment, a VCN, and then there is obviously a display name and whether it's enabled. So in this case, I'm creating an internet gateway. Okay. Yeah, as I said, all resources are very extensively documented. Check the provider-specific information, and also there are lots of examples on GitHub on how to use them. Okay, resources. Here we go. Just to put it back together, there is a cloud entity type. You give it a name, and then you populate the various fields within that resource type. And again, they are all documented. About the variables, just like I said, most of the time you find the examples contain a file called variables.tf. TF is the ending for Terraform files. In there, you define which variables you use. And you don't need to initialize those in your variables.tf file. You just kind of define what you want to use later. And the syntax is pretty good at that. You can give it a description and also a data type. And there are loads and loads and loads and loads of data types now with HCL2. The most common probably string, number. There is a map, and there is also a list. And those can take data types as well. So you can have a map of strings and so on. You can even assign default values. Although I don't really do this, I usually have a shell file where I define my variables. This is not going into version control at all. So it's part of my git ignore. It includes setenv.sh. And this is where I encode the variables. So Terraform takes the variable's contents. If you have an environment variable in your shell that's prefixed with tf_var. So you've got if you go back, I've got a tenancy OCID as a variable, and here I've got tf_var tenancy OCID. And if I source this into my shell, the values will be populated and I can run it. And this way I separate the implementation from my code. Okay, I might have said it before, but don't commit sensitive information into version control. It really isn't. You don't get hacked if you put your keys onto GitHub. Another worthwhile piece of information is about the output variable. So for instance, in my case, I'm creating a virtual machine, which is called an OCI core instance. And because that's the only one which has a public IP, I print the public IP at the end of it. So there is an output variable called Bastion host, and it prints the public IP at the end of the run when Terraform has completed. Yeah, and you reference this using the resource type, the resource name, and then the field you want. And again, the number of fields that are available are documented. So public IP is one of the fields within the OCI core instance. And then you've got a thing called a state file. So the state file understands what is currently deployed. And so if you go and change your code and run it again, it compares against the state. Say you want 5 VMs now, and it has already created 3, it will only create a couple more. So that's where it's declarative. And again, the state file is a vital piece of information. It shouldn't go into version control because it contains sensitive data in clear text. And there are various ways on how to manage your state, and it depends on your project and on your team size. But you can use remote state, but I would suggest if you use remote state, then make sure that you use remote state with a backend that supports locking. Otherwise, if you've got 2 people changing code at the same time, the one who finishes his activity last overrides the state from the person who's just done it before. Never ever commit the state file or other any sensitive information. It sounds like a broken record, but it's so important, so I gotta put it here again. And finally, there is an option to have modules and reusability. And there is an acronym called Don't Repeat Yourself. And you can do this using modules. And there is a blogger called Yevgeny Brinkman, also the author of Terraform Up and Running. I can only recommend this. He's got lots of good thoughts on how to modularize your code. And now that takes me to the little example I have prepared. I'm conscious of the time. So what I'm going to do here is I'm going to create the tiniest bit of infrastructure on the cloud. So I've got a Bastion server, which is accessible via SSH from an internet gateway. Then I've got a container host with an application connecting to an Oracle XE database, and all of this will be created by Terraform. This is, of course, reused to the maximum possible. You would never do something silly as that in production. No, I wouldn't say silly. Something as simple, because it's not a clever design. It doesn't give you resilience, and it doesn't give you any security. But it is good enough to get this example going. And so after you have reviewed the Terraform code, you've written it, you can run a couple of commands. One of them is called Terraform plan, which would give you a what if analysis. And if you're happy with that, you can then say Terraform apply, and then you just wait for the script to complete. And that's what it looks like. So you say Terraform apply, it will create resources. In this case, it doesn't, there is nothing that exists, so it doesn't remove anything. And it will create stuff. So it creates a couple of VMs, no, 3 VMs actually. And so it prints what it does, and then it asks you, are you okay with that? Do you want to perform these actions? And if you say yes, then it goes off and creates them. And that takes a little while. And after that little while, it has created your infrastructure. And the resources exist. So for instance, it creates VM instances. It creates my virtual cloud network with all the network security groups, which I have, the firewalls and so on. And it has also created all the routing tables. And with that said, just want to show you that it actually does work by running this little video. I hope it becomes visible. So I'm not a big developer, and what I did is I created a Tomcat host in Docker, and I wrote a little servlet, because that's really the basic example. And in here, all I'm asking for is a connection to a host name, a port number, and a service name. And this is running on the application tier. It connects to the database, and you can see I can use the Oracle DNS name. So the instance is xe instance1 at db.demovcn oraclevcn.com, port 1521, and then it connects when I click on the submit button. And a little later it says, yes, I'm connected, Oracle JDBC version 19.7, I'm connected as Martin. And essentially this is, if I go back and open my window and play, that's what it created. So don't have a mouse pointer, how annoying. I've got a Bastion server. I've got security lists, network security groups rather. I've got the various gateways also deployed, and I've got an application that I can deploy. And all of this has been done totally, completely hands-off. All of the infrastructure has been created as code. And I think at that point it's time to have a look at the questions, because I saw a few of those come up. If I can find them.
I have answered some of them, Martin. They were asking about the slides for your presentation.
Yeah, they will become available as usual. Okay, let me say. Oh, one in Spanish.
Yeah, let me go through that.
Oh yeah, you answered those.
Yeah, that was about the presentation. Also in the chat window, they were asking about if the session was recorded, which is correct.
It is, yes.
Will be published in the YouTube channel in upcoming days. And I think that's pretty much about questions. I don't see.
What I'm trying to do as well is I'm going to try and put those examples online. I've got a GitHub account, so if I get to it, and I'm going to create a blog post about this presentation and also link to my GitHub repository with the code. I mean, again, it's not brilliant code. it's the most basic example on how you can create infrastructure as code, but it is enough to get you started, I would like to think.
Okay, Martin. So I think if there are no more questions, we will be ready to wrap up and give thanks to the audience that was with you, Martin, throughout the session. It was pretty interesting. We are using Oracle Cloud Infrastructure. I think this is pretty useful for us. So we really appreciate your time, Martin. And for the Spanish speaking audience, gracias una vez más por la gente que se unió. Gracias por su tiempo. Recuerden que estamos en el track de Oracle Cloud Infrastructure. Hay 4 sesiones todavía en la tarde a partir de las 2 horas del centro de la Ciudad de México. Y los esperamos en estas sesiones. Recuerden que esto es Groundbreakers 2 Latinoamérica 2020. I think there are 4 more questions.
Yes, they just popped up.
Yeah. The first one is in Spanish. I'm going to,
okay.
For you, Martin, it says that there are some similarities with the CLI of OCI that there are some similarities with the CLI tool from OCI. That's what Marcelo.
Yeah, I think Marcelo was saying that. Yes, because it's the same backend API. So there are various ways on how to access the API, and using Terraform is one. But I have used the OCI CLI as well, and you can do pretty much the same with the OCI CLI. If it's one choice for you to go with. So yeah, you can use that.
There are two more. Can we create OIC instance using Terraform?
I think that's probably a typo when you say OCI instances. And yes, by all means, you can create everything. Well, I'm saying that now, but you can create OCI instances and other things via Terraform, the CLI, and the GUI. So there is various ways on how you can do those tasks. And finally, do I have a GitHub repository? Yes, I do. I've got it. I'll put it in the chat later. I can't type at the moment because my laptop is high. It would look rather weird if I typed. But we're going to. I think when we get to the sending the links out for the recording and the slides, then I'm going to share. I'm going to share the URL to my GitHub repository. If not, just search for it on Google. It's Martin Bach GitHub. It should come up. It's not very. I haven't populated a lot of stuff yet into my GitHub repository and public, but there certainly is from my Java blog posts. I've put something on there as well.
So last question that I can actually take it, Martin, because they are asking about SOA Suite infrastructure with Terraform in cluster high availability. And the answer is yes, you can do it. Actually now through the marketplace that Oracle has, Oracle Cloud Infrastructure Marketplace, you are able to do that. Actually, that's kind of the new way to provision those type of instances in a specific WebLogic and SOA Suite and so on. So there is already in the marketplace a way to provision SOA Suite. So it is actually a Terraform plan. So you can take a look to that if you will. And the last one is that if you can send the GitHub repo URL.
Yeah, like I said, we'll make that available once we send the slides and the notification about the slides out.
And we will take one more question and we will be ready to wrap up. And it is not in the Q&A section, but in the chat it says, can I integrate Terraform with Ansible to install packages and software inside machine? And is there any best practice to construct codes?
Easy to answer, yes. So the first step would be to create cloud infrastructure using Terraform. Like I said, you get kind of a naked Oracle, Linux, Ubuntu, Windows system. And then it depends on what you want to create on top. But yes, by all means, you can run Ansible on top of the cloud infrastructure that you have just created. And it's one of the very common ways of deploying things that I see. So yes, best practices. I'm not aware of best practices when it comes to Terraform. There's a really good book out there called Terraform Up and Running by Evgeny Brinkman, like I said. Make sure you get the second edition because it's updated and I think it's been released last year. But it's very, very good. And for Ansible, yeah, there are sort of best practices that are documented on the Ansible website. So a quick search for Ansible best practices should get you there.
Okay. So I think now we are ready to wrap up, Martin.
Okay.
It was a very good session, a lot of questions at the end. So I think that's always good. So thank you, Martin. Thank you for your time. Gracias a todos los que se unieron. Seguimos en el 6º día de Groundbreakers Tour Latinoamérica. Recuerden que hay todavía 4 pláticas de Oracle Cloud Infrastructure hacia la tarde. Thank you, Martin. Gracias a todos.
Okay. Well, thanks, guys. Speak later. Bye-bye.
Hasta luego. Bye.